I have to say that I was really impressed with the enthusiasm of the whole group. Everybody coming up with their own creations and sticking at it with day after day. That's really not easy when things don't work. I think that the most important thing that you've learned is that things never work the way you expect them, but there's somehow a way through.
Hi everyone, meet Latron James. So the original milestones for our project included having it go in a straight line and stop at a white line and then basically throw the ball into a basket at a designated distance away from the robot. And so this was measured from trial and error. What we ended up doing was finishing our milestones, and we wanted to make it a little more complicated by having the robot turn around. So it turns around a central axis and it detects the basket and then moves away or towards it depending on how far away it is, from between 34 to 36 centimeters away, and then throws the ball into the basket. Several things that we did about the design was initially we had all of the wheels sort of linear so that it only moves straight, but in order to make it turn, then we had to use 2 motors instead, and we had 2 motors each power 1 wheel each, and then we used the steel ball at the front to help it turn. You can talk about the code.
Okay, so we had like a few different main stages of the code. The first stage was the robot turning and trying to find the hoop, and then once it finds the hoop, it makes a correction to the angle because there's a bit of lag in the system, and so once it corrects for it, it makes a check to see if it's better, and then it will use a proportional control to go back or forth, and then find the correct distance to shoot the basket, basically.
Okay, so I guess we'll demonstrate it now.
Yeah. This is a robot, like it has a GoPros on it, and then it can take a video like along the wall, like in a room, so you don't have to be there to take a video of a room. It can be like a room inspector or something. So we put the brakes like in the bottom of the robot, and then we connect it with 2 wheels with the motors, and then we have a little metal ball in it, like at the back, and then on the top of it, we built a case to like fix like the camera, so the camera is pretty stable over here, and then it has little like a handmade like little kicker to like click the button of the camera. So yeah, and then we put like pretty much time to like how to figure that out, because it's like it looks like very easy, but like it's hard. Yeah. So and then we also put a ultrasonic sensor in the front, and it's not like going like directly straight, because it can like in this way like we turn it a little bit angle, so it can like sensor the side wall and also like the front wall. So it's only one sensor like can go.
Yeah.
No, it doesn't know
Trying
where.
to find on the wall.
We initially started off with a design of like a crane where you could just pick up certain colored objects and then go and drop them off at a certain distance. But then we were done with that too early on, so we thought we could add refinements to it. So what we basically did was that we decided that we could program it so that it would follow a certain colored path, and it can be programmed to follow any colored path, but the one that we chose was the red one. So it follows this path, and along the path, if it sees any green colored objects, it will pick them up and it will go and drop them off, and then it will reverse to show that it has dropped off the object. And do you want to talk about the construct?
Okay. Well, it has these wheels instead of normal wheels because sometimes when it goes over the object, it has to walk over it because it doesn't want to pick up blue or yellow things, so we need these. And it has a clamp that has several different things on it, like these things that push the unwanted objects aside, and it has this thing that retains what you want inside the clasp, so that when it opens again and walks forward to get the second thing, it doesn't lose the first one. So I think it's coming alive. Yeah. So yeah, and it has these wheels to stop the front part from being too heavy and making this thing touch the ground so it can't open. It's a lot.
Yeah, one of the problems that we encountered was that the weight of this brick became too heavy, so we had to attach like a roller ball over here for it to sort of be able to cope with it. We wanted to add some sort of autonomy to the robot, so we added a touch sensor. So every time that this button is pressed, this robot will start detecting the color, and when it's not pressed, it won't detect the color, and this is like sort of the switch. And then another problem that we encountered was with the color sensor, where we were using the same color sensor to pick up objects and to detect the line. And if it encounters a red object on a red line, it sometimes messes up.
It follows it.
Yeah, but it follows it, yeah. But yeah, that's just because we're using the same color sensor.
We made two versions, so we'll demonstrate the simple version first.
Yeah.
Okay. You want to demo and then I'll explain the program.
And if you move closer to it,
It will stop.
move closer. Oh, you won't go back.
Oh, it will stop.
I can turn.
So when it turns, the robot will turn and to find me.
And if you step back, you turn left.
If I turn right,
Yeah.
it will turn left and find me.
Oh,
And then turn back. Right.
oh, nice.
Yeah.
That's
But that.
You need to wait. The problem is that like when you turn in that direction, the robot will turn in the other direction, and
Yeah.
you need to wait for
So
the
you need to
robot
wait for it to
back.
turn back before it. Yeah. So, but we have another version which is
A little bit smarter,
Yeah.
but we're still testing it.
This is a little robot. It scans the board for these little red and yellow pieces, and it's waiting for me to make a move, so I'll just do it now.
That's pretty cool.
And then when I'm done making the move, I'll press this little button.
okay.
It dispensed the piece. Like played one. Yay!
Okay.
Ours is a line follower, and it started off looking a lot like Latron James over there. And with the two motors controlling each of the individual wheels, we decided to make it harder and more efficient turning, so we decided to go with a differential gear system, which is this. And what it does is these pieces distribute the drive. It drives it forwards, and the turning motor distributes the drive forward into the wheels, and whichever is the faster one gets the turn motor plus the drive, and then the other wheel, which is usually on the outside, gets the drive motor, or the drive motor minus the turn.
Yeah, so like one wheel will have drive plus turn motor power, the other wheel will have drive minus turn motor power, and then depending whether the turn motor power is negative or positive, the wheels will spin faster or slower in either direction. And so while we're demoing over here on our track, I'll explain the program. I have a light sensor that picks up a percentage of light reflected from the floor. Prior to this method, we used just discrete values picked up from like the reflection. So if the color was brown, we would oscillate towards the left to keep on the edge. If the color was white, we would oscillate towards the right to veer back towards the edge. So now we take the percentage of light and we measure an error. Along the line, there's a certain percentage of light reflected, and that's the target value. And then based on what value we get, like the white line reflects more light, the brown floor reflects less light. And so we check the error, and depending on that value, we adjust the motors as such using a PID controller. Another thing we implemented is we measure the integral as well as the error to see whether or not the car is on a straight line. And if it ends up being on a straight line, it will speed up, as you see right now. And final thing we implemented was for turns. If it realizes it's very far off course, it will adjust the constant of proportionality to turn much, much faster. And so now it will even out and go fast, and yeah.
All right, well done.
Basically, this is a basketball game, and there are three parts. This is the shooting machine part, and this is a basketball stand part, and this is a controller. So users can use the controller to basically control every motors here. So you can adjust the height here and the height of this one, and the power of each mode.
So like now we press these two buttons together
So try again.
Alright, this is our robot. We didn't give it a name because it's giving us trouble. And, so we actually started out with a different design, but we figured out that the pieces provided didn't allow us enough. The motors weren't strong enough to lift up the robot, so we came up with this alternative design, which actually climbed the step a lot faster and can climb much taller steps too, or the step. And so we stuck with the arc design, and we figured that this design, even though it does go over the step faster, it was a little bit unstable. So we had a lot of problems with making sure the wheels don't wiggle too much. And you might see that today, and you might not.
Yeah. Again, we made a lot of prototypes of this stair climber. This is our final right now, but we could adjust some things. We decided to put a touch sensor at the front, so when it pushes the stair, it'll actually accelerate, making it actually go up the stair and bring the back with it. Because we found that if it just goes straight into the stair, it stops and starts dancing. So.
So it goes slow at first, hits the wall. Oh!
Come on!